Sun, wind, and ocean interaction. Sun, earth, and weather. The sun is the source of most of the heat energy on Earth. Energy from the sun travels through space as electromagnetic radiation and enters the Earth's system through the atmosphere. Some of this energy is reflected and some is absorbed, but the remaining energy is absorbed by the land and waters on the surface of the Earth. The heat energy from the sun provides the fuel for Earth's weather. The latitude or distance north or south of the equator is a primary factor influencing the amount of energy received from the sun. However, since the Earth is tilted on its axis, areas of the Earth do not receive heat energy equally at all times during the year. The equator receives more direct sunlight regardless of the season, while the poles receive much less radiant energy year-round, but especially during winter season. This uneven heating causes differences in the temperature and pressure of large air masses. Because of the density differences in these air masses, areas of warm, humid air rise while cooler, dry air sinks. This pattern of circulation with warm, low-pressure air rising and cooler, high-pressure air sinking is another form of heat transfer called convection. Convection currents in the atmosphere form global wind patterns. Global winds caused by the convection of air masses are a major factor in creating Earth's weather. The diagram above shows the pattern of global winds and atmospheric convection cells caused by the uneven heating of the Earth's surface. Wind and water. How do global winds influence the ocean? Think about what happens when you blow on hot cocoa to cool it off. The surface of the hot cocoa moves in the direction of your breath. The wind you produce drags the liquid on the surface of your cocoa. Wind moves ocean water in a similar way, creating surface currents, a continuous movement of water along a certain path. Earth's major surface currents are shown below. Surface currents are driven by global winds that blow for long distances over the ocean surface. Because Earth is rotating, the winds blow in a curved path. Since the winds move in a curved path, so do the ocean's surface currents. This effect of Earth's rotation on the path of global winds and surface currents is called the Coriolis effect. This effect can be observed on the water in the sink as it drains. It rotates in a counterclockwise direction, the same direction Earth spins. Winds or waters that originate near the poles carry high pressure, cold air or water. Winds or waters that flow from near the equator transport lower pressure, warm air or water. As you can see, the Earth's oceans and winds act as a system to distribute and equalize heat energy around the globe. Some important things to note from this reading. The heat energy from the sun provides the fuel for Earth's weather. Remember, the sun is our energy source, and that transfer of energy is what's going to drive the weather patterns around Earth. We know that the Earth is heated unevenly. We talked about the tilt when we talked about seasons. Because of this uneven heating, we get different temperatures in different regions, which results in different air pressure, air masses. These different air masses are what are going to drive the weather, creating convection. Now, when we talk about this last paragraph here with the Coriolis effect, you have to understand because of the Earth's rotation, the wind and the water flow or blow in a curved pattern. It's not a straight path. So the spinning of the Earth results in the changing direction of the actual wind or the water. It's called the Coriolis effect. If you want to observe it, do what they say. Fill a sink or the bathtub with water. When you pull the plug out, watch how the water flows down the drain. It doesn't go straight down. It's going to go in a circular pattern. Because of this uneven heating, they have to be able to transfer energy throughout the Earth. Imagine if you lived at the poles and you couldn't get any of that warm water or warm air from the equator. It would be extremely cold. Same thing with the equator. It might be too hot if we couldn't cool it off some. So this movement of this energy through the oceans and through the air is what helps to regulate the temperatures on Earth.